Hello, welcome to the next SEM tutorial. In this part of the session, we'll have a look at some good practice concerning preparation data for SEM. The tutorial will cover two sets of tips concerning the preliminary analysis that you may run in SPSS before you go into amos, and some adjustments to SPSS spreadsheet that will help you with amos analysis. Let me start with preliminary analysis. Aside of checking data for errors, missing values and the pattern of distribution, I like to run two types of checks in SPSS. First, I assess Cronbach alphas to have a preliminary take on how reliably my scales perform. Secondly, I like to compute item means for each of my constructs and run the correlations to check for early indications of any problems with the structural model. I have opened a spreadsheet containing variables that are not behaving quite as well as one would wish to. To calculate Cronbach alpha, you go to Analyze, Scale, Reliability Analysis, and pick up your variables. I am interested in oppositional attitudinal loyalty, which is marked here from OAL1 to OAL7. I'm going to find those variables in my spreadsheet. Starts from there's another brand and finishes off with there is another brand. Right. Click, enter the items. Go to statistics and click this item here, scale if item deleted. That tells you what happens to the scale if you remove an item. Click continue. OK, and we will get our Cronbach alpha. As you can see, it's quite high already at 0.905. But if you look in detail into this item to total statistics, you will notice that if you delete the last item, the output tells you your scale will actually improve. It will go up to almost 0.92. This last item, there's another brand I believe is fairer, is a possible candidate for deletion. You will also notice that this item is poorly correlated with the rest of the scale, with the rest of the items, and that will show in your AVE estimates. It will lower it down. Let's try another scale. This time we will look at this brand material value. Again, I'll go to Analyze, Scale, Reliability Analysis, and this time I will pick items which start I admire. Oops, I'll remove those. I admire people and finishes off with I'd be happier. Right, go. OK, look what happens now. The Cronbach alpha is appallingly low. We are looking for something that is 0.7 or above. This is bad indeed. And you'll see that this badness is shown here in item to total correlation. Some of our items are actually negatively related to others. They will have to be deleted. What has happened? The original scale includes some negative statements, and in preparing the data for analysis, we have reversed those statements to align with all others. Unfortunately, the respondents did not quite get this and got confused, continuing to rank the reverse statement as if they were positive. I see this problem time and time with reversed items. In general, it's good practice to include them to alleviate response bias, but they have never worked for me, and every time I use a reversed item I end up deleting it from the final scale. What do we do here? My advice would be to delete the most offending items, including all the negative questions. And then the bad news is that the scale will be left with just 4 items which might be further purified in CFA. In general, I tend to begin deleting items in SPSS and following Cronbach alpha results. I refer to this procedure as measure purification. However, it is possible to carry items forward and delete them at the stage of CFA. It is possible, but whether it's advisable, that's a different matter. The first issue is that once you start deleting items from your CFA model, you may be accused for respecifying too much. Hare mentions this magic figure of 20%. And when you respecify too much, then you may be asked to collect new data. Secondly, when models get complicated and include many indicator variables, it becomes very difficult to see which variables cause you problems and which should be eliminated. I delete items ahead of CFA to cut through this complexity of interpretation. I also mentioned to you that I like to compute item means and then see how the correlations behave. How it's done? I go to the menu called Transform, Compute Variable, and then find here on the right hand side Statistics and a mean, double click it, and then compute a mean of a variable. Remember there is another, so we will compute a mean of oppositional attitudinal loyalty by just entering each and every of its indicator variables here in the equation. Oops, they have to be separated by commas. I'm just going to stop at 6 because I didn't like that 7, remember? And then we'll call the target variable oppositional attitudinal loyalty mean, right? Click OK, and at the bottom of your variable list, you will now see a new thing popping up called opposition attitudinal mean. Why I do it? So I can see how the variables correlate. Let's take this oppositional attitudinal loyalty. I have computed the means earlier and correlated with another couple of constructs. I'll take product involvement and brand material value. To compute correlations, you go to Analyze, Correlate, Bivariate, and then put your variables. My means are at the bottom. Alright, so we'll take means of all AA, means of brand material value, and we will take this means of product involvement. Okay, what we get is a table that shows that how strongly those means are correlated, which is an indication of how strongly your constructs may be correlated. Remember that I mentioned to you that SEM will enhance the relationship, but it will not diminish it. So it's just an earlier indication of how good the structural model may be. I can see here that this oppositional loyalty is strongly related to brand material value and moderately related to product involvement. However, you will see here that product involvement is not related to brand material value. So if you had a structural path working from product involvement to brand material value, it's probably not going to work. The last issue I would like to talk about concerns the organization of the SPSS spreadsheet, and my advice centers on two issues. One, naming of your variables, and two, sequencing of them in the spreadsheet. Both have to do with the list of variables that gets pulled into your viewing menu when you click the icon List Data in Amos. You will recall that when you list variables, a box pops up which contains variables name. These variable names then appear against your indicator variables, against the squares in your model. You will also recall from our earlier exercises that all the variables in my spreadsheet had abbreviated names like JS1 or P4. My first piece of advice is to use such abbreviations for names of all your variables in SPSS. That is, to replace in your SEM ready file the original names of variables with abbreviations. This will help you to see the variables in Amos list and in Amos model. If you keep the originals, you will simply not be able to see much on your Amos graphic model. My last piece of advice is to reorganize the listing of variables in such a way so the list in your SPSS file follows the sequence of your constructs in Amos. I group items together by construct and then I organize them starting from items in my first construct and finishing with the items on the last construct I am going to draw. With complex model, this approach helps me to draw a model and prevents me from making mistakes. And with this point, I conclude my remarks concerning data preparations for SEM. The next topic will concern modification of models. I'll see you shortly. Bye.